Okay, the next thing we're going to focus on is something called duality. And duality, sometimes we'll just refer to it as the dual. Okay, so what this really comes out to, it's another way to modify an expression. And it's going to be used to get something that ends up having a similar feel to it. It's a little bit like the De Morgan's, but it's not that we have to have a bar over it. Okay, so where do we start with this duality is let's look at some of the theorems we've been talking about. So if we look at some more Boolean algebra theorems, and you might see these in the book. They're all going to be numbered, and some of the numbers are going to have a D next to it. So for example, the book will say, I have theorem number 1, which is x, y, ORed with x, y bar, that's equal to x. And then right next to it, you'll have 1D, which says x plus y quantity with x plus y bar is equal to x. Then you might see something like number 2, which says x plus xy is equal to x. And then you'll have 2D next to it, and it'll say x with the quantity of x plus y is equal to x. Okay, so this whole section here, this is showing the dual property. So how do we find the dual? Well, the way we're going to find the dual is, let's say I have an expression, and that expression is f of a, b, c, and d. I can say I'm going to find fd, and that will be that we're going to do the dual property to it. So how does this look is, let's give it to variables. So let's say I have an a plus a b plus a c plus a d, dot, dot, dot. Maybe we have quite a bit of letters. And then when we say I'm going to find the dual of it, this will be converted into that I'll have a dot b dot c dot d. So we're going to see that in here, a plus became a dot. So we're going to change the gates. The gates are going to go plus moves to a dot, and is going to move to an or. What is different than the De Morgan's is that our variables stay the same. Variables stay the same. So an A stays an A. A B bar stays a B bar. Other items we would see happen is we might have, if you have a 0 becomes a 1. And if you have a 1 will become a 0. So let's look at these expressions we have. Let's look at number 1 on our theorems. So number 1 said x plus, sorry, got that wrong. X and the y, or with x, y bar is equal to x. So let's say we take this and we're going to do the dual on it. Okay, so what are we going to do? Is let me put in the dots because those are going to change. Okay, so in these items, let me put extra brackets. So let's say we have brackets. I have x dot y. That's a term. That has to be in a bracket. Plus an x dot y bar. That's in its own bracket, and that's equal to x. Okay, we're going to do the dual on it. Okay, so let's take this item in blue. I'm going to make a change I'm going to say the and becomes an or, a y, and an x. And that's going to stay with brackets. Then let's do this plus in purple, the plus in purple. The or becomes an and. And then let's do this term in green. In green, I have a term, so I have parentheses here. The and is going to become an or. The variables come down. And then that is, equal to x. We don't change anything with the variable. Okay, so let me just clean this up all in black. That says is x plus y bar is equal to x. Okay, so let's go up and let's look at what 1D will be. And we see 1D is the exact same item that has been modified. Okay, so let's do it on a different term. Let's apply it on something where you got to manipulate both sides of the expression. Okay, so let's do number 3 on our theorem, which is x plus x bar y is equal to x plus y. And in 3D on our little sheet there is saying that it's x ended with x bar plus y is equal to xy. Okay, so let's take this and let's do the dual on this part. All right, so we're going to apply the dual on that equation. Now, we're applying it for the entire equation. This is where this dual is different than De Morgan's. In De Morgan's, we didn't have it equal to anything. We just took the full expression and we did the modifications. Here we have an equal, so we're going to apply it to both sides. Okay, so I got x plus, and I'm going to put this in parentheses, x bar ended with y. So that ends up being the same, x plus y. And I'm going to take that whole quantity. I'm going to apply the duality on it. All right, so let's start on the right-hand side. So that in green, I'm going to take the plus, the or becomes an and it's y, x. Okay, I have equals. Let me take this item in red. I'm going to apply the duality to it. The and becomes an or, and then I got y, x bar, and that's a term. I have this plus. The plus becomes an and then I still have this x. The x, there was nothing to work on it. Okay, so I have this term. Let me just clean it up. So that's x ended with x bar or y, which is equal to xy. And if we look at this, we see, yep, they match. I got the same item. So that was the dual property occurring. All right, so that's how we take a dual property, which would mean, if you were to learn all of your theorems, you only need to learn half of them because you can apply the dual to get the other half.